Have you ever looked up at the night sky and wondered, where is everybody? That's the crux of a question that has puzzled scientists and stargazers alike for decades. It's the question that sparked the Fermi paradox, a perplexing contradiction named after the brilliant physicist Enrico Fermi. This paradox grapples with the apparent inconsistency between the high probability of extraterrestrial life and the striking lack of contact or even evidence of such civilizations. Now, to understand this paradox, let's first step back and consider the immense scale of our universe. It's estimated to contain more than 100 billion galaxies, each teeming with an average of 100 billion stars. When you start crunching those numbers, it becomes almost inconceivable that Earth is the only planet in the entire universe to harbor life. The Fermi paradox came into being during a casual lunchtime conversation. In the summer of 1950, Enrico Fermi, along with a few other physicists, was discussing the recent surge in UFO sightings and the possibility of faster-than-light travel. As the conversation progressed, Fermi suddenly blurted out, "But where is everybody?" His question wasn't about the UFOs or aliens, but about the high probability of advanced civilizations within our own galaxy, and the puzzling fact that we've had no contact with them. This paradox is named after Fermi, not because he was the first to consider the contradiction, but because he was the first to frame it in a way that sparked significant scientific and philosophical debate. It's a question that has led to countless theories, speculations, and more questions. And while we've made incredible strides in space exploration and our understanding of the universe, the Fermi paradox still stands unresolved, challenging our notions about life beyond Earth. It's a riddle that continues to probe the unknown, pushing us to question, to explore, and to seek answers. So the big question still stands. If life should be plentiful in our vast universe, why haven't we found any signs of it? To understand the Fermi paradox, we need to understand the Drake equation. Now, what is the Drake equation? It's essentially a probabilistic argument, a mathematical formula, if you will, that aims to estimate the number of active, communicative extraterrestrial civilizations in our Milky Way galaxy. Let's break it down. The equation was proposed by Frank Drake, not for the purpose of quantifying the number of civilizations, but intended to stimulate scientific dialogue at the first scientific meeting on the search for extraterrestrial intelligence, or SETI. The Drake equation incorporates 7 variables. Each one represents a key factor that would contribute to the existence of advanced civilizations capable of interstellar communication. First, we have the rate of star formation in our galaxy. Then, the fraction of those stars that have planetary systems. Next, we look at the number of planets per solar system with an environment suitable for life, followed by the fraction of suitable planets on which life actually appears. The next 2 variables delve into the realm of the complex, the fraction of life-bearing planets where intelligent life emerges, and the fraction of civilizations that develop technology that releases signs of their existence into space. Finally, we have the length of time such civilizations can continue to release detectable signals. Each of these variables is shrouded in uncertainty. Yet when plugged into the Drake equation, they yield a wide range of results, from less than 1 to more than 1 billion civilizations in our galaxy alone. This brings us back to the Fermi paradox, named after physicist Enrico Fermi. If there are potentially so many civilizations out there, where is everybody? Why haven't we detected any signs of extraterrestrial intelligence? Despite the vast numbers produced by the Drake equation, we remain puzzled by the silence. It's a mystery that continues to baffle scientists and inspire dreamers. But the search for extraterrestrial intelligence, driven by equations like Drake's, continues unabated. One solution to the Fermi paradox introduces a concept called the Great Filter. Imagine a cosmic hurdle, a critical juncture that all life across the universe must navigate. This is the essence of the Great Filter theory. It suggests a stage in the evolution of a species so challenging, so incredibly difficult to overcome, that it prevents civilizations from significantly colonizing the universe. The Great Filter, in essence, is a hypothetical event or series of events that drastically reduce the likelihood of life progressing to an advanced stage. It acts as a barrier, a bottleneck, if you will, which few, if any, civilizations manage to break through. So, what could constitute this Great Filter? It could be anything from a devastating natural disaster such as a colossal asteroid impact or a supernova, to self-inflicted catastrophes like nuclear warfare or a runaway climate change scenario. The possibilities are as varied as they are terrifying. One of the most intriguing aspects of this theory is its implications for humanity. Have we already passed the Great Filter, or is it lurking ominously in our future? If we have already passed it, this might suggest that we are one of the few, if not the only civilizations, to have successfully navigated this cosmic gauntlet. Perhaps the development of complex life itself is the Great Filter, and we are extraordinarily rare in the universe. On the other hand, if the Great Filter is yet to come, it presents a more worrying prospect. It may suggest that our civilization is destined to encounter some insurmountable challenge that will prevent us from ever reaching the stars. This could potentially explain why we have yet to detect signals from other civilizations. This brings us back to the haunting silence that Fermi Paradox contemplates. Are we alone in the universe? Or are we just the lucky survivors, the cosmic lottery winners who have already passed the Great Filter? If the Great Filter is ahead of us, it might explain why we have yet to make contact. The Fermi Paradox has given rise to a plethora of other hypotheses. Among these, the Zoo hypothesis, the Transcension hypothesis, and the Rare Earth hypothesis stand out, each proposing a unique perspective to the paradox. The Zoo hypothesis is fascinating in its own right. Imagine we live in a sort of cosmic zoo, observed by advanced civilizations, but left undisturbed. It's as if they've drawn a do not disturb line around our solar system. They watch from a distance, allowing us to evolve and grow without interference. It's like a wildlife preserve where the animals are unaware of the observers outside their environment. This hypothesis suggests that the reason we haven't made contact is because these civilizations choose not to interfere with our natural development. Then there's the Transcension hypothesis. This suggests that advanced civilizations invariably leave our universe, essentially transcending this reality. It's a grand idea. It proposes that as civilizations advance, they shrink and accelerate their thinking, computation, and communication. Ultimately, they disappear from the universe as we know it, into a domain we can't perceive or interact with. If this holds true, it would explain why we haven't heard from anyone out there. Lastly, we have the Rare Earth hypothesis. This theory implies that the conditions for intelligent life are so rare and specific that Earth might be one of the few, if not the only place where it has evolved. It takes into account the many factors that have allowed life to flourish here, from the presence of water to the right distance from the sun, and suggests that such a perfect combination is extremely rare. These are just a few of the numerous hypotheses that have been proposed to explain the Fermi paradox. Each one offers a unique perspective and potential explanation for why we've yet to make contact with extraterrestrial life. All these hypotheses take a stab at explaining the silence, yet none can conclusively solve the paradox. While we have yet to find definitive answers, the search for extraterrestrial life continues. We are, in essence, explorers driven by an innate curiosity to understand the universe and our place within it. This curiosity fuels our relentless pursuit for answers, not just about our own existence, but also about the possibility of other life forms in the cosmos. The search for extraterrestrial intelligence, or SETI, exemplifies this spirit of exploration. SETI scientists operate on the frontier of knowledge, listening to the cosmic noise, hoping to discern a signal, a pattern, something that suggests we are not alone. Their work, while yet to yield definitive results, represents an essential part of our collective quest to understand the universe. In addition to the wide-reaching efforts of SETI, we're also exploring closer to home. Mars, our planetary neighbor, has been the subject of numerous missions. Rovers like Perseverance trundle across its barren landscape, drilling into the Martian soil, searching for signs of past or present life. We may not have found little green men, but the discoveries of water and organic molecules hint at the potential for life. Our exploration doesn't stop at Mars. The icy moons of Jupiter and Saturn, Europa and Enceladus respectively, harbor vast oceans beneath their frozen surfaces. These moons offer another tantalizing possibility in the search for life, and future missions are already being planned to investigate these distant worlds. The search for extraterrestrial life is not just a scientific endeavor. It's a journey of discovery, a quest driven by our desire to understand the universe and our place within it. It's a testament to our boundless curiosity, our refusal to accept the unknown without question. As we continue to probe the universe, to listen for signals in the cosmic noise, to explore our neighboring planets and their moons, we are reminded of the enormity of our task. The universe is vast, and we are but a tiny speck within it. Yet we persist. As we continue to explore the vastness of the cosmos, the question remains, where is everybody?
Please do like, share, and subscribe to my channel. Thanks for watching.